Here we go, guys, doing 10.2b. It's still the same section, but we're doing the second half of 10.2. We already covered thoroughly arithmetic sequences, and now it's time to move on to series. So let's jump right into our notes here. I would title it 10.2b. We're focusing in again on the series portion. So let's begin our notes by writing down the word series, and let's define what series actually means. A series is a summation of the terms of a sequence. Now, what do I mean by summation? That's simply when you add up all the terms of a sequence. So to get a better understanding of this, let's look at an example. And here's an example. By the way, I hope you guys are keeping up with all this in your notebooks. Find the sum, find the sum of -7 plus -3 plus 1 plus 5 plus 9. You see, these numbers right here, it's a list of numbers. It really is a sequence. And to be more specific, it's an arithmetic sequence. How do I know it's arithmetic? Because there's a common difference. 9 take away 5 is 4. 5 take away 1 is 4. 1 take away a -3 is 4. -3 take away a -7 is 4. That is an arithmetic sequence. But because it has a plus sign between all the terms, we're not going to call it an arithmetic sequence anymore. We're going to call it an arithmetic series. Okay? So the question is, what is the answer to this math problem of simply adding these terms? So -7 and -3, that's -10. Plus 1, that's -9. You could do -9 plus 9, that would cancel out. So your final answer here will be the answer 5. Okay, let me put a equals 5 right there. That's the answer to that summation right there. However, that's not what we want to do, right? This is the long road. It's logical, right? It makes total sense. Add this and this and this and this. But there's a shortcut, a formula that we want to memorize. Because, I mean, think about this. What if I gave you this example over here? Please jot this down. Now, this right here says find the sum of -7. It's the same numbers. But at the end of the 9, it says plus ... What does ... mean? That it continues. Now, if you didn't have this other stuff, it would continue forever. And of course, the summation would be infinity. However, it does have a ... which means that it ends at this final number 89. Okay? So, yes, you could say that the common difference is 4, right? -7 plus 4 is -3, plus 4 is 1, plus 4 is 5. Plus 4 is 9, and you could keep going. Plus 4 is 13, and then 13 plus 4 is 17, and then of course you got to add up all those numbers. The formula that we want to memorize for this section is the summation formula for arithmetic series. Okay, what does summation mean? That you add up all the terms, kind of like we're doing here. This is a summation right here, and there's a summation formula for arithmetic series. Okay. In the future, we're going to learn a summation formula for arithmetic or for geometric series as well. But right now, the arithmetic one is this. And this is straight from the book. I guess I probably shouldn't have. Well, this is the title that they write in the book. The sum, and this is the notation, S sub n. Okay? S sub n, kind of like A sub n is A sub n is the nth term of your list. S sub n is summing up your list all the way to that nth term, okay? So the sum, S sub n, that's a notation of the first n terms is, and here it is, sum of however many numbers you have will be however many numbers you actually have on your list times, parenthesis, your first term plus your last term divided by 2. Okay, let's understand that. Again, the notation. Let's begin with this notation right here. Whoops, sorry about that. The notation S sub n. What kind of notation are we used to? We're used to A sub n. A sub n is just, we're used to this guy. And what does A sub n mean? If there's 17 numbers in the list, then A sub n would be A sub 17, right? If you want to talk about the first number, that would be A sub 1, right? That makes sense. So what does S sub n really mean? It means the summation of however many numbers you actually have. So like, let's say there was 17 numbers on the list, right? A sub 17. Now, whatever that 17th number is, it could be 100, it could be 1,050, I don't know. But if there's 17 numbers on the list, then this would read S sub 17. And what does that mean? That you're going to sum up all those 17 numbers using this formula. So if you did have S sub 17, then this n would be 17 because there's 17 numbers on your list. Whatever your first number is, it might be 3, it might be -7, whatever. Put that first number there. Add it with a sub n. If there are 17 numbers, and this should be your 17th number, whatever that 17th number is, add them, get an answer, divide by 2, and then multiply it by however many numbers are on the list. So please jot that down in your notes. Now let's actually go to the, let's go to the book and look at those examples. So we have by the way, the book gives you more formulas. I'm just focusing on the key formulas, the important ones, key concepts. And let's look at example 4 from the book. As a matter of fact, let's take this example 4 and let's jot it down in our notebooks. Easy for me, I just cut and paste, right? So you guys, please jot down this example 4 right in your notebooks. There you go, I cleaned that up. So we don't want to show any of the work, we're going to actually work through this. So it says find the sum of 12 plus 19 plus 26 plus ... So logically, you could be like, all right, what's happening between 12 and 19? Oh, I'm adding 7, right? 12 plus 7 is 19. And then 19 plus 7 is 26. And then 26 plus 7 is going to give me the next number, and then that next number plus 7 gives me the next number till you go all the way to the number 180. And then after having that entire list, you have to add up all those numbers. You know how long that would take? Forget about it, right? It's easier to have this arithmetic series formula that we have up here, right? So we want to be able to use this formula, but what are the things that we need to be able to use this formula? Well, we need to know how many numbers there are on the list, right? And we need to know the a sub 1. Okay, so far we know the a sub 1 is 12. We also know the a sub n. A sub n is the last number on your list, all right? So you have the first number on your list plus the last number on your list divided by 2, and then times however many numbers there are on your list. So the problem is we don't know the n. Okay, that's the problem, okay? So let's begin with what we do know. What do we know? We know how to write the a sub nth rule of any arithmetic sequence. So let's write that a sub nth rule. The a sub nth rule is a sub n, this is from yesterday, of course, or from the first half of this lesson, is your first term, a sub 1, plus n minus 1 times the common difference d, okay? So our a sub 1 term is 12. We have the plus parenthesis n minus 1 times the common difference. So what is a common difference? Let's take any number and subtract the previous number from it. So if I go 26 take away 19, that's 7. If I go 19 take away 12, that's 7, right? So my common difference is 7. Okay, so right here I'm just going to put the d equals 7. The common difference is 7. And again, how do you find that? By taking a number and subtracting the previous from it. So on this variable d, I'm going to put times 7. So now I need to simplify so I could get my actual a sub nth rule. So what do I have here? I have a sub n. A sub n equals, distribute the 7 times n, that's 7n. 7 times -1, that's -7. Bring down the plus 12. So what we really have is a sub n equals, what's 12 take away 7? That's 5. So again, let me rewrite this thing. A sub n equals 7n plus 5. Here's the a sub nth rule, the machine, the function machine that produces this list. Okay, so believe it or not, I could plug in the number 1 right here, it'll give me 12. I could plug in the number 3 and it'll give me the third number on this list. So what do we know here? We know the machine that produces the list. If I wanted to, I could plug in a 4 to get the 4th number on the list. I could plug in a 5, the 5th number on the list, and I could keep going till I get to the 180 to see which term gives me 180. So let's use algebra instead of logic. A sub n, that's the last number on your list, it's 180. So since you already have this rule, take the 180 and plug it in right there into the a sub n. Okay, so what we have here is 180 equals 7n plus 5. Now, why would I do that? Again, you plug in what you know to find out what you don't know. And what is it that we don't know? We don't know how many numbers are on the list. We don't know the n, right? So if I plug in what I know, that a sub n is 180, and here's my function machine, plug in the 180 for a sub n, and now you'll be able to solve this equation for n, and that will tell you how many numbers are on the list. And again, you need that n value to be able to do the summation formula. Okay, so let's solve this thing. We're going to subtract 5 on both sides. We have 175 equals 7n. Divide by 7 on both sides. And your final answer for n is 25. N equals 25. Okay. Now, we found the function machine that produces the list, just like we've been doing for the past couple of days, for the whole week. And now we plugged in what we know, the 180 for a sub n, to be able to find out what n is. And now that we know n, now we could go back and use the summation formula for arithmetic series. So let's write down that summation formula. S sub n, let me do the n in red since we got the n equaling 25 in red, equals n times your first term, which is a sub 1, okay, plus your last term, which is a sub n, all divided by 2. Okay? So once again, let's actually plug in our values so we could get our summation answer. So we're going to have S sub, we know that n is 25. Okay? So this is just saying, this is a notation that the summation of the 25 numbers on your list. See, we now know that there's actually 25 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to 25 numbers. The 25th number is 180. Okay? So the summation of these 25 numbers will equal the n value, which we said was 25, times your first number, which we clearly see is 12, plus your last number, which we just said was 180. And then you take those two numbers, add them together, divide them by 2. So 12 plus 180 is 192. We will be dividing by 2, and we will be multiplying at the end by 25. And that will be the summation of those 25 numbers. So let's divide 192 divided by 2. So we end up with 25 times 96. So when you actually multiply 25 times 96, you'll figure out that the summation of those 25 numbers, if you add up all those numbers, you will get 2,400. Yep, there's your final answer. So if you actually were to go 12 plus 19 plus 26 plus the next numbers plus all, there's 25 numbers in this list. Your final answer, when you hit equals on that calculator, it will be 2,400. Okay. It's pretty easy to use the summation formula if you know how many numbers are on the list, right? Let's actually go back in our notes. Now, we did this first one. This first one was ridiculously easy. We could just go -7 plus -3 plus 1 plus 5 plus 9. We get the answer equals 5. But you know what? Just for funsies here, let's actually apply the summation formula. So the summation formula reads S sub n equals n times your first term plus your last term divided by 2. Now, I know it'd be ridiculous to use a formula right here because the answer is 5. It's really easy to add these 1, 2, 3, 4, 5 numbers up. But we just counted them. There's 5 numbers on this list. So if I wanted to continue with the formula, it would say S sub 5, because I'm going to be adding up the 5 numbers on this list, equals, so there are 5 numbers on this list, and we're going to be multiplying 5 times the fraction, which is your first number, a sub 1, which is -7, plus a sub n, which is your last number, 9, and then we're going to divide that by 2, and then at the very end multiply it by that 5. All right, so what is -7 plus 9? That is +2. So what we have here is 5 times +2 over 2, which is really just 5 times 1 which means that the final answer is the summation of these 5 numbers is 5 times 1 is 5. As you could see, same exact answer, just using the formula instead of actually adding them up. So again, it gets a little more tricky when we have missing values, okay? And when we have missing values, that's when we have to first use the a sub nth rule that we've been using, create the machine that produces the list. Then you could plug in your last number into a sub n. That way you could solve for n, and now you could actually use the formula by plugging in that n value that you've solved for and knowing your first number and your last number. You'll be able to see the first and last number from this list right here. First number, last number. Not only are they going to ask you to find the summation of an arithmetic series, but they're also going to give you some information about an arithmetic series and ask you different questions. Like right here, it says find the first 3 terms, the first 3 numbers on your list of this arithmetic series, which has your a sub 1 being 7. Okay, you have the first number so far, but you need the next 2 numbers, right? It's a total of 3 numbers that they want, the first 3. The first one's 7. And now if we had a common difference, we'd be able to say the next 2 numbers. All we'd have to do is add the common difference to the next 2 numbers, but we don't have a common difference. There is no variable d equals here. What do they give us? They give us an a sub n equaling 79, and they give us an s sub n. They actually tell us that if you add up the list of numbers, that your answer would be 430. So you know what? Let's not look at the work that they do here. Let's do it ourselves. So let's jot down this problem in our notebooks. So in this problem right here, it says find the first 3 terms of the list. Now we only have the first one, and we don't have a common difference. So let's write down the formulas that we know. Let's start with the a sub nth rule. A sub n equals a sub 1 plus parentheses n minus 1 times that common difference d. And the other formula that we know, which is the summations of an arithmetic series, which is s sub n equals however many numbers there are on your list times parenthesis a fraction, and up on top we have your first term a sub 1 plus your last term a sub n divided by 2. Okay, so those are the 2 formulas that we have. Why did I write down both formulas? Because I need to know what to plug in where. Okay, so if I plug in my a sub 1 term right here, that's great, but I don't have a common difference. So, and I don't know how many numbers are on the actual list. So if I plug in a sub 1, I'm still going to have 2 missing variables, n and d. So it probably would not be smart to start with this one. I mean, if you did start, you'd get stuck. But over here, what could I plug in? What do they give me? Well, do I know the first number on the list, a sub 1? Yes, it's 7, so I could plug it in right there. Do I know the last number on the list, the a sub n? Yeah, it is. I do know it's 79. I could plug it in right there. Do I know n? No, I don't know n, but I do know this entire s sub n, the actual answer. The actual answer of adding up the numbers on the list is s sub n equaling 430. Okay, so once again, you write down your formulas, you see what they give you, and see which one you would be able to solve. Okay, so on this first one, I have a sub 1, they don't tell me n, and they don't tell me d. So I'd have 2 missing variables, and you can't solve an equation for 2 missing variables, right? Even if you did have a sub n being 79, you'd have 2 missing variables. You can't solve an equation if it has 2 missing variables. You can't get a letter by itself because there's 2 letters, right? Now, if you look at this one, you could plug in the s sub n 430. You could plug in the a sub n 79, the a sub 1 7. You could plug in everything, and you have a single letter that you could solve for. So let's do that. Let's plug in s sub n being 430 equals n, we don't know, times parenthesis first term 7 plus last term 79 divided by 2. Okay, so what is 7 plus 79? That is 86. So let's write that down. We have 86 divided by 2 times n equals 430. Okay, so 86 divided by 2, that's 43. So what we really have is 430 equals n times 43. And of course, you want to get n by itself. You don't want that multiplication of 43 divided by 43. divide by 43. 430 divided by 43 equals 10. 10 equals n. Ladies and gentlemen, we just found out how many numbers are on this arithmetic series. There's 10 numbers total. Okay? So we found the n value, which means that now we could actually take this n value of 10 and plug it in right here where the n value is at, right? So we already know that a sub n is really a sub 10, okay? So let's work this out. That way we could get our actual machine that produces the list, and if we want the first 3 terms of the list, all we have to do is plug in 1. Actually, we don't have to plug in 1, we already know it's 7, but then you plug in 2 and 3, and you get the next 2 terms, okay? Or you could find out what the common difference is, and then just simply add the common difference to 7 2 times. Anyways, let's plug in what we have now. A sub n equals 79, and we know that it's really a sub 10, all right? So let's do that. We have a sub 10. We'll write down that it equals 79 in a moment, equals a sub 1. A sub 1 is 7, plus n minus 1, but we know that n is 10, times that common difference d, and the common difference d we don't know. Okay, that's what we're figuring out for right now. So what is a sub 10 really, right? Because we could solve for d right now, but the thing is we want this to be a number, not actually the notation a sub 10. We don't want it to be the notation of the 10th number. So what is a sub 10? A sub 10 is really that last number. The a sub 10 is 79, right? So we have 79 equals 7 plus 10 minus 1 is 9 times d. So let's subtract 7. Subtract 7. We will have 72 equals 9d. Divide by 9, divide by 9, d equals 8. D equals 8. So now we could actually write down our rule, or we could just say, okay, the common difference is 8. So if my first term is 7, so if my a sub 1 is 7, that means that my a sub 2 will be adding that common difference 8, which will be 15. And a sub 3 will be adding that common difference 8, which will be 23. So your answers are right here. The first 3 terms, 7, 15, 23. Okay. Or the other option is to go back and continue to write your a sub nth rule by plugging in a sub 1, plugging in your common difference, distributing that common difference, combining like terms, and then you get your actual a sub nth rule that'll produce the entire list. You could find any number you want. The first 3 terms, the 17th term, the 100th term, whatever you like. But anyways, that's the answer for that example. And that's what they explain in the book. Right now would be a great time to pause. So I want to end this video here because we have another type of notation, but I don't want to overwhelm you. Okay, so let's just stop right there and focus in on these type of problems that we just went over. On the next video, we'll pick up on the sigma notation, which is just a notation for series, for summing up the numbers on your list. And we'll get to that on the next video, or the next half of this lesson. Right now, I do want to jump into practicing what we went over. So our homework assignment, well, everything's from home, right? So it's kind of pointless to call it homework. Your assignment for today is to do page 671, numbers 43 through 51, skip 47. Okay, so there's not that many questions to do. How about this? I'll do probably half of them right now. Let's do it. Let's do number 43. So the instructions say, find the sum of each arithmetic series. So we have a list right here. Let me rewrite it in my notebook. So here's the question 43, and we want to find the summation of this entire list. We have all these missing numbers. So I have negative 18 plus negative 15 plus negative 12 plus negative 9 plus negative 6, and so on and so on. I already know that the common difference is positive 3. How do I know that? You pick a number and you subtract the previous number from it. So let me take the negative 15 and subtract the previous number, negative 18, from it, which the minus minus changes to plus plus, and you end up with negative 15 plus 18, that is 3. So the common difference is 3, and it doesn't matter which ones you do it to. You could actually go negative 12 minus a negative 15. It's going to be negative 12 plus 15. You're going to get that same common difference, 3. That's why it's called the common difference, because that difference is the same between all of its terms. All right, so we have this list. We know the common difference is 3. Let's use the summation formula or the a sub nth. Let's write down both formulas. The a sub nth rule, the machine that produces this list, comes from a sub n equals a sub 1, the first number on your list, plus parentheses n minus 1 times that common difference d. And the summation formula is a summation of however many numbers you have will be however many numbers you have times your first number plus your last number, a sub 1 plus a sub n, divided by 2. Okay, so the question is, what do we have so far? Do we have an a sub 1 that is needed for both of those? Yeah, we have an a sub 1 that's negative 18. Do we have an a sub n? Yes, we do have an a sub n that's 66. Do we know how many numbers there actually are on the list? Well, we don't know how many numbers are on the list, so we don't know n. Okay, so if this was a sub 17, that would mean that the 17th number on the list is 66. So we don't know n, so we can't really use this one. Why? Because even though we have a sub 1 and a sub n, we have the first number and the last number, we don't know how many numbers there are, and we don't know the answer to the summation of however many numbers there are. So there's two missing things here. We don't know how many numbers there are, and we don't know the answer to the summation of all these numbers. So it's not like you could plug in these numbers. You'd still have two missing variables. You only want one missing variable, so you could actually solve for that. So let's take a look at this guy over here. A sub n. Do we know a sub n? Yeah, it's 66. Do we know a sub 1? Yeah, it's negative 18. Do we know the common difference d? Yeah, it's 3. So we could plug in a number, and we will have only one missing variable, which means we could solve for that n. All right, so let's do that. And the a sub n value is 66. Equals a sub 1, that a sub 1 is negative 18, plus parenthesis n minus 1 times the common difference 3. So let's solve for this missing variable n. So let's distribute the 3 times n, 3n, 3 times negative 1, negative 3, bring down the plus, the negative 18. We still have the equals 66. So when I combine the negative 18 with the negative 3, I'll get negative 21. So on the right side of this equal sign, I'll have 3n minus 21 equals 66. So I need to solve for n. Let's get rid of that minus 21 by adding 21. Adding 21, we will have 87. So we have 87 equals 3n. Final step, divide by 3, n equals 29. So n equals 29. So we found n, which means now we could actually find the summation of these 29 numbers. There's actually 29 numbers on this list. Now, if you wanted to, you could go back and find the actual a sub nth rule, but they're not asking you to find the 17th number on the list. They're asking for the summation. So let's just take what we have now and plug it all in to the summation formula. So we have the summation of those 29 numbers equals those 29 numbers times your first number, which is negative 18, plus your a sub n, your last number, which is 66, divided by 2. Again, a sub 1 is your first number, a sub n is your last number. So you're adding your first number with your last number, plugging it into the formula. There are 29 numbers. We figured that out by solving for n. And now let's work this out. Negative 18 plus 66 is 48. So we have a 48 divided by 2 in the parentheses times 29. 48 divided by 2 is 24 times 29. That will give us the summation of these 29 numbers. So the answer is 696. So we figured out that the summation of these 29 numbers is 696. So if you actually went through with the common difference D, adding 3, 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 till you get to the number 66, you'll realize that there's 29 numbers in this list, and then you'd have to add them all up, like get a calculator, go negative 18 plus negative 15 plus negative 12 plus negative 9. Imagine adding 29 numbers on a calculator. That would take way longer than the algebra that we just did. So there's our answer, number 43. I believe now you are ready to do 44. It's the same exact thing. I'll provide the answer so you could check your work. So please, if you want to, pause right now, try to do 44, and then check your answer. So the next questions, 45 and 46. I believe this one's easier. They give you that first term. So I think you guys will be able to figure that one out as well. I'm going to do 46 because they don't give you a sub 1. So let's do 46 together. And on 46, again, you want to find the summation of your list. You want to actually add them all up. And you can't even see the list here. We know that there's 19 numbers, but we can't even see the list. So how could we even add it up logically? We can't. So let's again begin by writing down the two formulas that we have to have memorized. And then we're going to think about what they give us to see which formula we're going to go with, right? I know they want us to find the summation. This is the one we ultimately want to do to find the final answer. But let's see which one we could use, right? So they give us an n. So you could plug in an n right there. They give us an n, you could plug in an n over here, all right? So far, so good. They give us an a sub n. An a sub n is 154, which means I could plug in 154 right here. I could also plug in 154 over here. They give us a common difference d8. So there is no d over here, but there is a d over here. So we're not going to be using this one. We're going to start with this one, okay? Why is that? Because when you plug in n, you'll have a number right here. Plug in a sub n, you'll have a number over here. Plug in d right here, you have a number right there. The only missing one will be that a sub 1 value. And that's a very important value because you need it for the actual summation one. You need the a sub 1, and they don't give you the a sub 1. Question 45, they do give you the a sub 1, which is why I believe 45 would be a little easier for you than 46. Anyhow, let's start with this guy. Let's plug in the a sub n value, which is 154, equals a sub 1, we do not know, plus n minus 1. They're telling us that there's 19 numbers on the list, so 19 minus 1. And then the common difference they tell us is 8. So let's put times 8 right here. Don't distribute because you could actually take away 19, take away 1. That'll be 18. So what we have here is 154 equals a sub 1 plus 18 times 8. PEMDAS tells you to multiply before adding. 18 times 8 is 144 plus a sub 1 equals 154. Subtract 144 from both sides and you will get 10. A sub 1 equals 10. The first number on your list will be 10. Okay, so going back up here, they give us n, they give us a sub n. We just found out a sub 1 is 10. The first number on our list is 10. And we already know the common difference d. So now we are able to take everything that we have, all the information that we have, and plug it into the summation formula. Okay, so we're going to sum how many numbers? This is just the notation saying we're going to sum up 19 numbers. We don't even know the 19 numbers, but we're going to sum up those 19 numbers. And it's going to be equal to 19 times the fraction. And up on top of that fraction is the first number plus the last number. The first number is a sub 1, which is 10. We found out what that was. We're going to add it to the last number, which is a sub n, which is 154. And let's work this out. We're going to have 19 times 154 plus 10 is 164 divided by 2. 164 divided by 2 is 82. So we really have 19 times 82. And that will be the answer to the summation of these 19 terms. Adding them all together, that is. So the answer is 1,558. S sub 19, adding up the 19 numbers on the list will give you 1,558. I hope you guys understood number 46. You guys could probably do 45 now. Same method. We're skipping 47, and we're jumping to 48, 49, 50, and 51. I guess I'll do 48 and 50, and you guys could do 49 and 51. Number 48, let's write down the two formulas. I know some of us are thinking, I'm not going to write them down, I already know them, but you know what? Write them down, it'll help you memorize them, all right? So what do they give us? They give us an n, which means we could plug it in right there, or we could plug it in over here. They give us an a sub n, which is negative 86. A sub n's here, negative 86. A sub n's here, negative 86. And they also give us an s sub n. Now, s sub n is not here. Okay, so it looks like all this information they give us, we could plug it all into this. So we're not going to go with this one. We're going to plug it all into this one. So let's jump right in. So instead of s sub n, we're going to say s sub 32. So there's 32 numbers on this list, equals, again, 32 numbers times the a sub 1, which we do not know. Okay, we don't know a sub 1. They don't, if you look up here, there is no a sub 1. There's an a sub n, but there's no a sub 1. So let's put a sub 1, since we don't know it, plus a sub n. Now they do give us an a sub n. A sub n is negative 86. Oh, it's kind of ugly, I apologize. Let me actually, and it is divided by 2. So let me rewrite this thing. Now, I want to solve for a sub 1. However, this should be a number. So instead of s sub 32, I'm actually going to write down 224. Because remember, s sub n is saying that if you add up all your numbers on the list, we don't know what that is, but actually we do, s sub 32, your answer will be 224. So s sub 32 is really 224. Or we could have immediately plugged it in, the s sub n value, could have just plugged it in right here to this s sub n and skipped this part right here. So we will have 224 equals 32 times a sub 1 plus negative 86 divided by 2. So let's start solving for a sub 1, which is clearly on the right side of this equal sign. I need to get rid of this 32 by dividing by 32. That'll cancel out. Divide this side by 32. That will give you the answer 7 equals, there's no need to write the parenthesis anymore because you already got rid of the 32. So we have a fraction on this side. And what do we have? We have a sub 1 plus negative 86. Or you could just put minus 86 if you want. Let's actually do that. Let's put a minus 86 right there. Divided by 2. Okay, so you don't want the divided by 2, so go ahead and multiply both sides by 2. And you will get 14 equals a sub 1 minus 86. To get rid of the minus 86, you add 86. Add 86, and you will get 100. So we end up with 100 equals a sub 1. Okay, so we have found out that our a sub 1 term is 100. So our first number on the list is 100. So we might as well jot that down up here on the information. A sub 1 equals 100. Now we gotta think, what are they asking for? Are they asking for the actual summation? No, they tell us what the answer is. It's 224. What are they asking for? On the instructions, it says find the first 3 terms of this list that has 32 numbers in it, right? So we want the first 3 terms. So far, we have the a sub 1 term, which is 100. We figured that out. Now we need the next 3 terms. If I had my common difference d, then I would just add that common difference to 100, and that would give me my second term. Then I could add that common difference to my a sub 2 term, and that would give me my a sub 3 term. But the thing is, I don't have my common difference. I need to solve for common difference, so let's plug in everything that we know into the a sub nth rule to find out that common difference. So a sub n is negative 86, so let's plug in negative 86 equals a sub 1, which we said was 100, plus parenthesis n minus 1, which is 32 minus 1, times the common difference d, which we do not know. So I apologize, it's getting messy. Let me put that line to separate my work. So let's do the math here. What is 32 take away 31, or 32 take away 1? That's 31. So I really have negative 86 equals 100 plus 31 times d. Okay, let's subtract 100 to both sides. We'll end up with negative 186 equals 31 times d. Let's get rid of the 31 by dividing by 31, giving us a final answer. Common difference is 6. Negative 6, that is. So we now know the common difference is negative 6. Let me write that down right here. The d is negative 6. All right, so what are they asking us for? The first 3 terms. We just said a sub 1 is 100, which means that the next term, a sub 2, that'll be 100 minus 6, which would be 94. And then the next term, a sub 3, will be 94 minus 6, which will be 88. So these are the 3 numbers, 100, 94, and 88. Those are the first 3 numbers on our list. So now that we just did 48, I recommend you hit pause and try to do 51. It's the same exact information provided, same exact process. Try to do 51. Check your answers on the PDF that I attached to this section. And then let's do the next one, 50, which is almost identical to 49. I'll do 50, you do 49. So again, let's begin with reiterating the instructions. They want you to find the first 3 terms, right? A sub 1 equals whatever that is. Oh, and they give it to us 3. A sub 2, we want to find out the second term. And a sub 3, we want to find out the second term and the third term, all right? They give us a sub 1. If we had a common difference, like if they said the common difference is 5, would you go 3 plus 5? That's 8. 8 plus 5 is 13, and we'd be done. However, they don't give us a common difference. So let's write down our formulas to see which formula we're going to utilize to plug in the values that they give us. So they give us an a sub 1, which could go here, and it could also go here. They give us an a sub n, which would go here. They give us an s sub n, which would go there. Okay, so let's plug it in to this summation formula. Why is that? Because a sub 1, that'd be a number. A sub n, that'd be a number. S sub n, that'd be a number. The only missing variable would be n, which you could actually solve for. If you plugged it in over here, a sub 1, you don't know n, so that'd be one variable, one missing variable. You don't know d, that'd be another missing variable. So you only want to pick the one that where you plug it in, it'll only leave you one missing variable, so you could actually solve. So instead of s sub n, let's write down 759 equals, we don't know how many numbers there are on this list. We do know that a sub 1 is 3. So if you add that first number with the last number, a sub n, which is 66, and then divide it by 2, you'll be able to solve for that missing value n. So let's do it. 3 plus 66, that is 69, divided by 2, times n equals 759. Now, what we could do here, instead of getting rid of the fraction, you could get rid of the fraction by multiplying both sides by the denominator 2. Or you could get rid of this fraction, which is really a number. It's the multiplication of this number by dividing by that exact number, right? So if you divide by 69 over 2 by that same exact number, it'll cancel out. So you'd have to divide by 69 over 2, which would mean that if you actually rewrote this, instead of dividing by a fraction, let's multiply by the reciprocal. You could rewrite it as 759 times 2 over 69. Of course, that would equal n, right? So when you multiply this through, of course, use a calculator, you're going to end up with 1,518. If you multiply 759 times 2, it's going to be over 69. That equals n. And if you divide 1,518 divided by 69 on a calculator, you get 22. So your n is really equal to 22. Okay, so what are they asking us? They're asking us for the first 3 terms of our list. So we already know the first one's 3. We need a common difference to be able to get to the next 2. So we're going to have to plug in everything that we know into this a sub nth rule to be able to solve for that d, that common difference that we need to get to these next 2 numbers. So let's plug in what we know. What do we know? We know a sub n is 66. So instead of a sub n, let's write down 66. Of course, I got that from here. A sub n equals 66. We have equals a sub 1. A sub 1 is 3. Okay, so we have a 3 right here. Plus n minus 1. What is n? We just found out that there's 22 numbers on this list. So let's plug in a 22 right here, minus 1. That'll be 21. Times that common difference, d. So that's what we're going to be solving for d. So what we have here is 66 equals 3 plus parenthesis 21 times that common difference, d. Let's solve for d. So you want to get rid of the plus 3, and then you want to get rid of the multiplication of 21. So let's get rid of that plus 3 by subtracting 3. We will have 63 equals 21 times d. Let's get rid of the multiplication of 21 by dividing by 21, and you will get 3 equals d as a final answer. So what does that mean? That the common difference is 3. So if your first number is 3, that means your second number will be 3 plus that common difference, 3, which is 6. And then 6 plus 3, 9. So the first 3 numbers of the list on number 50, given the information, will be 3, 6, 9. Knowing or understanding number 50, you guys should be able to do number 51, that last number, which is identical to this one. I apologize for this extremely long video. I mean, this is a challenging section. I hope you guys are all learning, and I hope you guys are all well and healthy. I will talk to you on the next video.